Okay, so you have different network types. Now we are going to study only two network types, say OSPF network types. Okay, so now let me tell you here. Yesterday we have used router 1 to router 2 connection. We have used serial cable. We have used serial cable. So this is serial and this is also serial. So this network type is called point-to-point network type. Point-to-point network type. Point-to-point network type. Point-to-point network type. Now you have one more, which is called, say suppose you can connect these routers using Ethernet interfaces or Ethernet type interfaces. It can be fast Ethernet or it can be gigabit Ethernet. It can be 10 gig and all. Okay, suppose I am connecting it with fast Ethernet. Both ends are fast Ethernet. Clear? So this is also fast Ethernet. This is also fast Ethernet. Now this is called Ethernet network. Sorry, broadcast network type. Broadcast network type. Okay, so it's called broadcast network type because, so let me first tell you why it is called point to point. This is called point to point because you only have a single point to another single point connection. Okay, it is connected from one single point to another single point. Here instead, let me tell you, so where is it? Okay, suppose you got, or you can keep a switch in between. You can connect a switch in between and you can add routers. So this is router 3 and this is also this is router 4. Okay, so R1, R2, R3, R4, and if at all you want, you can add one more router, R5. Okay, so whenever it is broadcasted, it will go to all the routers. Right, it will reach all the routers. And this called, and so it's called broadcast network type. Now let me tell you the problem with the broadcast network type, or if you implement OSPF in broadcast network type, there is a problem. Shall we talk about it? Yes. Okay, so suppose, so this is the diagram. You got 5 routers here, R1, R2, R3, R4 and R5. Now suppose that, say here OSPF, all the routers are implemented with OSPF. If all the routers are implemented with OSPF, say they will form neighborship or they will form adjacency. Okay, neighborship or and adjacency. Okay, neighborship and adjacency both are different, but adjacency will also form. Now the problem with forming adjacency is that, say R1 will form adjacency with R2, R3, R4, R5. Okay, now R2 will also form adjacency with R1. They have already formed adjacency. Okay, now R3, R4, R5. R3 will form adjacency with R4 and R5 because say R3 also already formed adjacency with R2 and R1. Okay, now R4 will form adjacency with R5. So everyone will form adjacency with each other. That's the problem. Okay, means R1 to R2, R1 to R3, R1 to R4, R1 to R5, and again R2 to R3, 4, 5, R3 to R4 and R5, R5 to R4. So everyone will form adjacency. So if they form adjacency like this, okay, the total number of adjacencies can be found out by an equation n into n minus 1 by 2. N into n minus 1 by 2. So the thing is that how many adjacencies will be there here? If you have 5 routers, 5 into 4 divided by 2, so 10 adjacencies will be formed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 adjacency will be formed. Okay, so that is the problem here. So if at all the adjacencies are formed, means everyone will be sending the LSAs to each other unnecessarily. Okay, and lot of say adjacencies and lot of neighborship or adjacency will be formed, will be creating complexities. Okay, so now if you have 100 routers, how many neighborship will be there? If you have 100 routers, 100 into 99 divided by 2, that means 9900 divided by 2, around 4500. Okay, around 4500 adjacencies will be formed, and that is the issue. Okay, now to reduce the number of adjacencies and to reduce the complexities here, okay, so let me write it here. It is 4500, around 4500 adjacencies will be formed. Now to reduce the complexities, what we will do is that we will assign a router as a leader router. We'll assign a router as a leader router, or we'll make a router as the leader router. Okay, so now let me tell you, suppose the leader router is R5. R5 is the leader router. So R5 being the leader router is called DR. It's called DR, or it's called designated router. It's called designated router. Okay, now R4 will be selected. If you have a leader, then you will have a backup leader as well, right? In the classes we will select a leader and a backup leader. Okay, so suppose R4 is the backup leader. R4 is the backup leader, and this is called backup DR. It's called backup DR or BDR. So backup designated router. Backup designated router. And all others are called, say, R1, R2, R3. R1, R2, R3. All are called DRO. All are called DRO, or designated router others. Designated router others means those are not the designated router, those are other than the designated router. Okay. Okay, now so you got a DR, BDR and 3 DROs. Now DR will form adjacency with everyone. So here DR, so let me tell you, DR or R5. Okay, DR, the thing is that DR will be forming adjacency with everyone, means DR will be forming adjacency with BDR and also with all the DROs. Okay, now BDR, who has already formed the adjacency with DR, will now form adjacency with everyone. Okay, suppose we are selected a leader. Suppose Anish is the leader. Okay, and suppose Ashwin is the backup leader. So Anish, being the leader, should know everyone's phone number. Okay, so that doesn't mean that you need to know the number, it's just for example. Okay, now Anish, say, being the leader, needs to know everyone's phone number. So you guys will be sharing Anish. So you guys will be forming friendship and say best friendship with Anish, and you will share your phone numbers. Similarly, the BDR, I mean the backup, in case if Anish doesn't come, if Anish doesn't come, and Ashwin will be the leader. Okay, BDR will be the DR. Okay, then so Ashwin also needs to know your numbers because he is the backup. Okay, so you need to form adjacency, means friendship with Ashwin as well. Clear? Okay, now if at all Vaman and Deva. Okay, Vaman and Deva. So Vaman and Deva, they are the usual students here. They are DROs. Okay, now DRO to DRO neighborship means, say I am telling Vaman shouldn't share, or say Deva and Vaman, they shouldn't share their contact numbers with each other. Okay, means DRO to DRO, it's adjacency. Okay, so let me again tell you, DR to BDR adjacency will be formed. Okay, and DR to DRO adjacency will be formed. Again, BDR to DRO adjacency will be formed. Again, DRO to DRO adjacency should not be formed. Clear? DRO to DRO, it's not neighborship. DRO to DRO adjacency should not be formed. Clear? So here in our case, say R5 being the DR, R5 being the DR forms adjacency with everyone. So R4, R3, R2 and R1. Now R4 being the backup designated router will already form adjacency with the DR. Now will form adjacency with DROs R3, R2 and R1. So how many adjacencies now are there? Say 1, 2, 3, 4, 5, 6, 7. You have reduced the adjacency to 7 adjacency. Clear? So now what happens is that if at all, okay, and again you guys know that tomorrow is a holiday. Okay, so tomorrow is a holiday. Okay, now if at all tomorrow is a holiday, Anish will be calling you and Anish will be informing you, right? Say you or everyone has shared their number to Anish, so Anish will be informing you. So what happens is that if at all R1, R2, R3, R4 and R5 they form adjacency with the DR. Okay, with R5 means everyone will form adjacency with R5. Then R5 and everyone will send the routes to R5 as well. Everyone will send the routes to R5 also. Now R5 will run the SPF algorithm. R5 will run the SPF algorithm and will send the routes to everyone. And will send the routes to everyone. Getting it?
Yes.
Okay. So this is what happens. Okay. So now if at all you have, say here the number of adjacencies is 7 only. The number of adjacencies is 7. What if you have 100 routers? If you have 100 routers, one DR will be there, one BDR will be there, okay, and 98 DROs will be there. Now one DR or DR, this DR will form adjacency with the BDR. That's the first adjacency. Now this DR will form adjacency with the 98 DROs. So again 98 adjacency is formed. Now again BDR will also form adjacency with 98 DROs. So again 98. So total number of adjacency will be 98 plus 98 plus 1. How much? 190? 187 or 197? 197. So whereas if you didn't go with this method, you could have got 4,500 adjacencies, which will be very, very, very complex. Now that you have reduced the complexities and you only have 197 adjacencies. Now again 100 routers are not going to be connected like that, just telling you the example. Okay, yes. So this is what the problem with the broadcast network type, and we have solved it by using by designating a router as DR, another one as BDR, and the DR to BDR and DR to DR adjacency will be formed, and BDR to DR adjacency will also be formed, and yes, DR to DR adjacency not formed. Clear? Okay. Now shall I show it to you?
Yes.
Okay, suppose I have taken the GNS3, but unfortunately, okay, and yesterday I didn't I forgot to show you the packets, OSPF packets, right? Live packets I forgot to show you. Usually I would be showing that, that's why I take the GNS3, but yesterday I forgot. Okay, no worries, if at all we have time today, I'll show you. Okay. So guys, just give me a moment. So okay. Now guys, let me tell you here, let me take open Salman, okay. Both. So guys, can you see at the back? I mean, can you read at the back? No. Okay. So let me expand it. Okay. Now can you read at the back? Okay. So let me. So you got 5 routers. You got 5 routers here. Okay. You can see. So instead of R1, R2, R3, R4 and all, I have R3, R4, R5, R6 and R7. Okay. Just replacing the numbers with say 5, 4, 3, 2, 1. Just replacing it with 7, 6, 5, 4, 3. Okay. So suppose this is say. Okay. Just replacing all the numbers here. So R7, say suppose, where is R4? This is R6. Okay. Or where is it? R5, R4 and R3. Similarly, suppose let me write it here. Suppose R7 is the DR. Suppose R7 is the DR. So R7 will form adjacency with R6, R5, R4, R3. Okay. Now let it be there. So now R6 being the BDR will form adjacency with R5, R4 and R3. Okay, so total 7 adjacencies will be formed. Okay, shall we check that? Now, so here this is the diagram and I have already assigned the IPs and all. Okay, so here the network is 10.00/28. So I might have assigned the IPs like this. Say 10.00/28. Okay, so dot 3. This is 10.003. This 10.004, 10.005, 10.06 and 10.007. Okay. Now if I turn on the router, okay, and I suppose I might not have done the OSPF. Okay, I'm not sure. Let me check and we'll do the OSPF here. Okay, so yes, it may take some time. By that time, let me type the commands. Notepad. So router OSPF 1, suppose. Okay, and network say 10.0.0.0. Okay, the network address is 0 only. Okay, and the wildcard mask is for /28. What is the wildcard mask, guys? Can you find it out faster? 0.0.0/28. Not at all. Yes, woman. Any answers? 15. Yes. So it is 15. And area, suppose everything is in a single area, 0. Okay. Now let me exit and yes, let me also give. Okay, let me first give it. Okay. So now R3. I suppose I might not have done any show IP protocols. We don't have anything. OSPF is not done. Okay. So let me go to the config. So here config T. Okay. Now, I suppose there will be a small, yeah. Now let me type one more command. Do clear. You will understand later why this is given. Okay. OSPF process. Okay, now OSPF is done and this command is to recalculate the SPF algorithm. This command is to recalculate the SPF algorithm. Now afterwards it will form neighborship and all. Okay, it will form neighborship and it will form adjacency. Okay, so let us wait for some time. So now it shows down and up. Okay, because we have again rerun the SPF algorithm. So again it will take maybe a minute or two to come up. Okay, so by that time let me implement one more command. Okay, so do show IP. Yes, you can see the neighborship has come up. Okay, or the adjacency has come up. So now do show IP OSPF neighbor. This is the command to view the neighbor table. Okay, if you check it, you can see R7. I told you, suppose R7 is the DR. It will form adjacency, means full adjacency with everyone. It will form full adjacency with everyone. So you can see it has formed adjacency with 10.003 R3. Okay, so this is R3. Now it has formed adjacency with R4, adjacency with R5, and adjacency with R6. R6 is the BDR. Okay, and R5, R4, R3, they are DR other. Okay, DR other or designated router others. Now, if at all, so we can't see any DR. Why? DR is not shown. Yes? R7 itself is the DR. R7 itself is the DR, and it cannot be seen in the OSPF neighbor table, right? Okay, it shows only the neighbor, and it itself is, so R7 itself cannot be the neighbor, right? Okay, to view its state, we will execute the command do show IP OSPF interface. Okay, or you can specifically mention that interface as well. Interface fastnet 0/0. Okay, interface fastnet 0/0, or interface brief as well. Okay, you can see interface brief. So you can see in faster than at 0/0, its state is DR. Its state is DR. Okay. Now again, do show IP OSPF interface. Okay, this command you can see. So here you can see, yes, fast Ethernet interface 0/0. It is having the IP 10.0.0.7/28, and the network type is, yes, area 0. Yes, area 0 as well. Now network type, you can see the broadcast network type. Network type is broadcast network type. Okay, now yes, coast is 10, you can see, and the state is DR. So DR ID is 10.0.0.7, and the interface address is also 10.0.0.7, and BDR is 10.0.0.6. that means R6 is the BDR. Okay, now interface address is also 10.0.0.6. Now next thing, the neighbor count is 4. They have formed neighborship with 4 people, and the adjacent neighbor count is also 4. That means adjacency also they are formed with 4 people. Who are those people? R3, R4, R5, and R6 is the BDR. Clear? Now, so R6, if you go and check the R6, you can see, say do show IP OSPF neighbor. Again, this R6 being the BDR formed neighbors, adjacency with everyone. So here with R3, R4, R5, and R7 they have formed adjacency. Now R7 can be seen, and this is the DR, full DR. Okay, full means it's a state, and this is DR. R7 is the DR. Okay, now again this command do show IP OSPF interface brief or interface. You can see the state is BDR and interface. Okay, so interface, you can see here the state is BDR itself. R6 is BDR itself. Okay, now so they are formed, neighbor count is 4, and adjacent neighbor count is also 4, because they are formed adjacency with 4 people. Okay, now shall we take any one of their DRO? Okay, so we got 3 DRO, R3, R4, and R5. Let me take R3. Okay, R3 being the DRO, do show IP OSPF interface brief. You can see it is DR other. Okay, DR OTH means other. Now let me tell you here, do show IP OSPF interface. Okay, or with just do show IP OSPF neighbor. Yes, now you can see it has formed adjacency with DR and BDR. It has formed adjacency with DR and BDR, and it has formed two-way neighborship. It has formed two-way neighborship with the DROs. Clear, guys? So neighborship is formed. Okay, so with the DR and BDR, you can see the adjacency has been formed here. Okay, now again the next command, do show IP OSPF interface. OSPF interface. Okay, so here you can see fastnet 0/0. Here it is 10.0.0.3, and you can see the state is DR other. Okay, now here the neighbor count is 4 and the adjacent neighbor count is 2. They have formed neighborship with 4 people with the DR, BDR and all the DRs, but adjacency has been formed only with 2 people. Who are they? BDR and DR. BDR is 10.0.0.6 and DR is 10.0.0.7. Any doubts? Okay. So this is the thing. Now you can ask a question. How will you find the DR? Okay, how will you find the DR? It's not a guess that I found out that R7 is the DR. There is actually a selection method. There is actually a selection method. Okay, so let me tell you the selection method. So now the router with, there is a value called priority value. There is a router called, there's a value called priority value. The router with the highest priority, the router with the highest priority will become the DR. The router with the highest priority will become the DR. Okay, now let me show it to you here. Okay, so the priority. Now let me just take R7 and configure do show IP OSPF neighbor. Okay, you can see everyone, whether it's DRO, BDR, everyone's priority is 1. Okay, and let me take R3 and execute the same. Even the DR is also having the priority 1. Okay, so this DR, I told you, whoever is having the highest priority, okay, whoever is having the highest priority will become the DR. But what if priority is same for everyone? What if priority is same for everyone? Okay, or the default priority is 1. The default priority is 1. If the priority is 1, or if the priorities are same, then they will check they will say the router which is having the highest router ID. The router which is having the highest router ID will become the DR. Getting it? Okay. Now, what is router ID? What is router ID? It is the value. It is like an IPv4 address. It is like an IPv4 address. Sometimes it can be an IPv4 address as well. Okay, so you can see the neighbor ID here. Okay, say this is the router ID, the neighbor ID, or this is the router ID. It's a 32-bit value written in IPv4 format. Okay, now how will you select the router ID? Let me tell you. To select the router ID, so here let me tell you the router ID for R6. Let us take a look at what is the router ID of R6. So for R6, say this is R6, the router ID is 10.0.0.6. it's the interface IP. Okay, now for R5 it is the interface IP. For everyone is the interface IP. Okay, let me tell you how to find out the router ID. So router ID, or it's called RID value. It's called RID value. This RID value is actually, you can manually give the RID value. You can manually give the RID value. We haven't given the RID value. Have we given the RID value? No. So you can first manually give the RID value. We haven't given the RID value. Okay, if you haven't given the RID value, the router will check for loopback interface. The router will check for loopback interface. Yesterday I told you what is loopback interface, how to create the loopback interfaces. Right, these are just certain virtual interfaces. Okay, so it will check for loopback interface, and the loopback interface IP will be selected as the read value. Yesterday we have set it. Okay, we have say configured the loopback interface. Today even there is no loopback. Okay, even I didn't configure any loopbacks here. Nor do we have any loopbacks here. Okay, so if at all the loopback interface are not present, they'll check the physical interface IP. They'll check the physical interface IP. If this fast Ethernet 0/0 is configured with 10.0.0.3 here for R3, and if at all you got a serial interface here, serial 2/0 with IP 20.0.0.3, okay, then the highest IP of the physical interface. Okay, physical interface here, this is one physical interface and this is another physical interface. The highest IP will be considered as the router ID. Getting it? Okay, so again let me tell you, the router ID, it's a value, it's a 32-bit value written in IPv4 format. Either you can give it manually. If you give it manually, then that itself will be the router ID. They will not do anything else. Okay. Now, if at all you haven't configured the router ID manually, then they will check for the presence of loopback interface. Then the loopback interface IP will be considered as the read value. If at all you do not have any loopback interface, then they'll check the physical interface. The physical interface will be checked and the IP address of the physical interface will be considered as the read value. Clear? So here the third method, say all the routers will now first check whether manually everything. So let me show you. See here in R8 I haven't configured OSPF. I haven't configured OSPF. So sorry, in R8 I configured OSPF. Okay, but let me tell you, here you may see something. When I try to configure OSPF, it is telling something. Please configure manually. Say cannot pick a router ID. Cannot pick a router ID. Please configure manually. Okay, please configure manually or bring up an interface with an IP address. Get in, guys? So I want you to write it down. Okay, I want you to write it down. This one. Okay, I suppose you can write it, right? Okay, just a moment. Okay, done. So now guys, so what happened here is all the routers first checked for the manual read value. Then we didn't set any manual read value. So they checked the loopback interface they didn't have any loopback interface. So they checked the physical interface. So the physical interface was set with an IP. So they took the IP or the physical interface as the read value. So here the read value is 10.0.0.3 for R3. Here the read value is 10.0.0.4 for R3. And here the read value is 10.0.0.5. Here the read value is 10.0.0.6. And here the read value is for R7, the read value is 10.0.0.7. Clear? Now they have selected the read value. The highest read value, the one which is having the highest read value, will be selected as the DR. So highest read value is 10.0.0.7. So R7 became the DR. Clear? Okay. Now the one with the second highest read value here, R6, is having 10.0.0.6, which is the second highest read value, which has become the BDR. Clear? Now, shall I change the read value of R3 now? Shall I change the read value of R3? Suppose that I am manually configuring it. Manually configuring the read value. So manual read, suppose that I am configuring manual read of R3. Okay, so R3 I am configuring a manual read. Suppose the read value is 11.0.0.1. Suppose just as read value. Okay, so 11.0.0.1. So shall we configure that? Okay, so in R3, if you configure the manual read value, then they will not check the loopback interface. They will not check the physical interface also. Okay, then this itself is the read value. Okay, so let me go to R3 here. So I'll go to R3 now and let me configure the read value. Okay, the manual read value. So we'll go to OSPF, router OSPF, then 1. Okay, then we'll mention the command like this, router -id, router -id, then the router ID, which is 11.0.0.1. Okay, now it is telling us to clear the OSPF, means we need to rerun the OSPF, then only it will take effect. Okay, so let me clear the OSPF here again. Do clear IP OSPF process, then we'll give yes. It will ask for confirmation, where I'll give yes. Okay, so now sorry. Unknown neighbor. Okay. The image I recalculate. Let me check. Okay, now that we have given the read value, okay, for R3, and now who is having the highest read value here, guys? R3 is having the highest read value. So R3 will now become the DR. Okay, R3 will now become the DR. And who will be the BDR? R7 will become the BDR. Again, shall we check? Now, if you take R3, so do show IP protocols. Do show IP protocols. Will show you the read value. Okay. Yes, the read value is now 11.0.0.1. Okay. Now do show IP OSPF interface brief. Okay. It has become the DR because it is having the highest read value. Okay. If you take R4 again, do show IP OSPF interface brief. Okay, so it's DR, sorry, do show IP OSPF neighbor. So you can see 11.0.0.1, which is R3, has become the DR, and 10.0.0.7 has become R7, has become the BDR. Any doubt? Okay. So this is how you will customize the broadcast network type. And again, there are some more things. Okay, I told you to select the DR. To select the DR, first they will check a value called priority. First they will check the value called priority. As the priority is same for everyone, as the priority is same for everyone, say, I mean everyone, by default the priority is 1. and that is why they have checked the highest read value. Yes, loopback is for the read value only. Okay, so here to select the DR, the other was to select the read value. Okay, now to select the DR. To select the DR, first they'll check the priority. Okay, so priority is now same for everyone, and that is why they have checked the highest read value. Okay, now what if the priority is changed? What if the priority is changed? Now I am changing the priority of R4. Changing the priority of R4. So now let me check the priority of R4 here. Shall we?
Yes.
Okay, so to check the priority of R4, let me go to R4 here. Okay, R4 itself, and everyone has got a priority of 1. You can see. Even the DR, which is R3 now, also got a priority of 1. Okay, now to check the priority of R4, do show IP OSPF interface brief. Okay, again you can see, where is it? No, it's on this is the process ID, it's not the priority. So let me check interface fastnet 0/0. Here they'll have the priority. Okay, yes, you can see the priority is 1. Everywhere the priority is default, it is 1 here on all the routers now. So if at all you want to change the priority, say R4 will have the priority of suppose 100. R4 is having the priority of 100. Then who will become the DR? R4 will become the DR because of the priority. Clear? Okay, so this has become the DR. Okay. Now again let me now who will become the BDR, guys? R3 will become the BDR. It's the BDR. Why it has become the BDR? Because of the read value, router ID.
Priority is same, so it will go.
Yes, exactly. So let me tell you, the priority is same now. For everyone the priority is same. So if priority is same, then they'll check the highest read value. So it doesn't matter, say this will itself be the DR. It doesn't matter if you got the read value, lower read value, first the priority will be checked. If the priority is greater, then that router will become the DR. Okay, then if the priority is same only, they'll check the router ID read value. So here, say everyone, say R3 has got the read value, highest read value among all the routers here. Okay, so he will become the BDR. Okay, so let me change the priority of R4. To change the OSPF priority, let me go to R4 itself, R4, and to that interface fast Ethernet 0/0. Then I'll mention IP OSPF 1 priority or IP OSPF priority. Okay, then you can configure the priority from 0 to 255. If 0 is configured, that means he will not be participating in the DR BDR selection. Okay, now say let me give 100 priority. Let me give 100 as the priority. Now again let me just rerun the SPF algorithm. Okay, so we have rerun the SPF algorithm. Again, it will take some time. Okay, for the neighborship to come up or the adjacency to come up, it will take some time. Okay, because again you can see to show IP OSPF neighbor. Okay, they have say become the two-way only. Again, it will take some time for the other. Again, you got lot of process inside. Okay, we are studying only some process. Okay, so again it will take some time, and then adjacency will come up. So the adjacency will be, say here everyone has formed neighborship, and after that everyone will form adjacency. Yes, now you can see adjacency has been formed, and now yes, still who is the DR? Yes, you can see DR is now 10.0.0.4, which is R4. Getting it? Because of its priority 100. Okay, now who is the BDR? BDR is R3 itself, right? R3 itself is the BDR. Okay, any doubt in this one? So this is how you will configure the OSPF or customize the OSPF in the broadcast network type. Okay. Now we are almost ending the OSPF. Okay, we are almost about to end the OSPF. Now let me tell you. So now what is left is that suppose you got R3. Suppose you got R3 here. R3 is there. Okay. Now, so again, let me take paint. So let me just tell you what happens when you configure the OSPF. Suppose you got R1, R2, and you got a network 10.0.0.0/24 network and 20.0.0.0/24 network, and this is 30.0.0.0/24 or 30 network. When you configure, suppose in R1 when you configure router OSPF 1, and when you go inside the OSPF, and when you give the command like this, network space 10.0.0.0.0.0.255 area 0. Okay, when you configure this, what happens is that two things happen. The first thing is that this network will get shared to the other router. That's the first thing. And the second thing is that through this interface they will send the hello packets. Okay, so again hello packets will be sent. It's actually unnecessary to send the hello packets, right? Because hello packets is sent to form or to find out the OSPF routers and to form neighborship and then form adjacency and all. If at all somebody else comes with a router and connect it unauthorizedly, they have connected, that means they will also form neighborship and all the routes this guy will also get. So you shouldn't be sending the hello packets. Clear? At the same time, this network should be advertised to the router also. Clear? For that we will configure a configuration called passive interface. We will configure passive interface. So in the passive interface, let me tell you what happens. If passive interface is configured, this network will get advertised to the other router R2. At the same time, they will stop sending the hello packets through that interface. Clear? Shall I tell you how to configure it as a passive interface?
Yes.
Okay, so there, suppose I'm in R3 and I'm going to R3 and I'm configuring the passive. I'm in OSPF and let me configure the passive interface. Passive -interface fast Ethernet 0/0. This is how you configure the passive interface. But if you configure this here, you can see everything has gone down. Any idea why it has gone down?
Because the hello packet is not sent, so the neighborship will not form, so adjacency will not be formed.
Exactly. That means, say, let me tell you, so this R3 has stopped sending hello packets. Okay, so that means he shouldn't form OSPF adjacency with each other. We have configured it as passive interface, so it shouldn't form adjacency with each other, and that's why the adjacency is dropped or gone. Clear? Okay, so again, this is the OSPF passive interface configuration. I suppose this also you got it, right?
Yes.
Sajin? Okay, everyone, right? Okay. So now let me tell you the last configuration of OSPF. So here, suppose you got R7. Now let me just tell you. Let me take R7. Do show IP interface brief. Include 0/1. Okay, unassigned fast and 0/1. So guys, let me give an IP here. Okay, the IP here I'm supposed to give 20.0.0.1. Okay, but I didn't give it. Okay, so
If we give it will form.
sorry.
If we give it will form
OSPF
what is the
adjacency.
neighborhood?
Okay, so yes. So but again here there is a problem. Here also I haven't configured an IP address here. So what happens is that here I haven't configured an IP address. So manual read value is not given, loopback interface is not given, and IP address is also not given. So OSPF can't work. Okay, and that is why the error came there. Say in R8 I've shown you an error, right? Please configure the read value manually or bring an interface up, because it cannot pick a route ID. It is neither configured with a manual read value, it doesn't have any loopback interface, it doesn't have any physical interface. So if you check do show IP OSPF interface brief, sorry, do show IP interface brief, you can see all the IPs are unassigned, all the interfaces are unassigned here. Clear? We do not have any IP, neither everyone is down also. Okay, so you need to have an IP and that interface should be up as well. The interfaces should be up also. Okay, now so R7. So in R7, suppose I configure that. Okay, do show or the interface FA 0/1, and I'm configuring IP address 20.0.0.1 255.255.255. Say suppose what is the subnet mask here /30. Okay, so 252.252. Okay, and let me configure no shut also, and here the same thing. Okay, interface fastnet 0/0. Okay, so 0/0. Then even if it's no issue, say if at all I didn't give an IP, because I don't want OSPF to run here. Okay, just making the interface up, that's it. That's my only intention. Okay, so now let me tell you, if at all the IP is configured and all, okay, in the real scenario we will have the IP configured and all, but now I'm too lazy that I don't want to configure. Okay, now so here R7 and R8 is the service provider. So R7 is connected to the service provider. So if at all R7 here, you got computers here. Now R7, in R7 you got a LAN, and from these LAN all these computers are trying to communicate to internet. Then to send the packets to the internet, what do you need to do? Which routing you need to do? Or which will be the usual thing? Are you sure it's static routing? EGRP. Oh, the usual. If at all it's a home router, it's not a big company router and all. If it's a home router, suppose it's a small home router, then if at all you want to send the packets to Facebook, you send the packets to Yahoo, send the packets to Google, send the packets to say Instagram, send the packets to whatever, Wikipedia, whatever it is, he will be forwarding it to the service provider only. And what is it called, guys? All the unknown networks should be forwarded to one guy. Whatever be the unknown, just forward it to him.
End router.
Yeah, this is the, suppose R7 is the end router. Okay, what is it called? All the unknown routes should be forwarded to the service provider. Whatever be the unknown route, it needs to be provided, or it needs to be forwarded to this router. What is it called? Directly connected. Did I teach you something called this one? Yes or no? Yes. And you're smiling. Okay. Yes, so I've taught you that. Okay, yes, imposition 10 times. Okay, nobody has answered, right? What is default route? Imposition 10 times. Okay, it's a shame, right? You should feel shameful. Okay, now, so we will configure a default route in R7. If R8 is the service provider, we will configure a default route in R7. How will we configure that? By statically mentioning it. By statically or by manually mentioning it. So shall I mention it? Okay. So now, so R7. Yes. എന്ത് കൂടിയ റൗട്ടർ? Actually, nope. Okay, we'll be configuring say you will have another, say, what do you say, okay, you can say yes as well. Okay, because let me tell you, from the router Okay, from the router it can be connected to the outside world, but before connecting it to the service provider, whatever be the router, you will configure many things there. Okay, you will study something called NAT and all, okay, later. So you might have configured that. Okay, so anything can be connected, all the routers can be connected there. Okay, so and again, the router that we use, the specific model, so that depends upon the topology that we have and the technology we support. Okay, so some routers say they use IPv6 also. So in that case, you will go with the router which is having IPv6 configuration. Okay, that depends upon the model also, okay, or the configuration also. Okay, now, so here let me tell you. Yeah. So I was telling that we'll be configuring default route in R7. Okay, so R7, let me just tell, say the default route, IP route 0.0.0.0, again 0.0.0.0, then we'll mention either the next hop or the, say, exit interface. Suppose I'm mentioning the exit interface, fast internet 0/1, suppose. So do show IP route. You can see the static route, S star, okay, or it's not the static route, it's a static default route only, star means candidate default here. Okay, so you can see 0.0.0.0/0, clear? Okay, so now here let me, just a moment guys, let me start the capture. And let me negate the passive config as well. Okay, let me negate the passive config here in R3. This is not related to this one, the previous config. Okay. Okay, now, so here whatever that happens will happen there. Okay, now say coming back to R7 here. So R7, we have configured a default route. In the routing table, you have a default route. Okay, statically mentioned default route. Now, suppose you got computers in R4. When these computers try to, say, ping to Facebook or Yahoo or Twitter, right? Everything, all the packets should be forwarded to R7. So what you will do? You will configure it manually. Okay, IP route 0.0.0.0.0. For every router, you need to configure like that, right? So let me tell you an easy method. R7 already has a default route. Yeah, so okay, so now, yes, so now let me tell you. So here, what is it? Yeah, so here R7 is already configured with a default route. Now this R7 here, it has a default route, and this default route can be injected into OSPF. So that R7 will propagate this default route or will advertise this default route through OSPF. Getting it?
Yes.
Okay, so we have configured a static route here, and this static route can be mentioned inside the OSPF, so that, say, this static route or the default route here can be sent to all the routers here. It is shared to all the routers. Okay, so shall we do that? Okay, so to originate that default route, we'll go to R7. And we will mention, we'll go inside OSPF, router OSPF 1, and we'll mention default hyphen, okay, information originate. This is the command, default hyphen information originate. And in some cases you will also use always as well. Okay, those things and all you will study in CCNP lab. Okay, where always is used, where originate is used and all. Okay, so now default hyphen information originate. Getting it? So let me tell you what happens. So here, do show IP OSPF neighbor. Sorry, do show IP root. Okay, so in R7 you have got a static entry 0.0.0 static default route is there. Now when you go to other routers, so when you go to other routers, suppose R3, okay, suppose when you go to R3, when you check, do show IP route, you can see the default route. You can see the default route. Where is it? This is it, 0000/0, and they have got it via OSPF. O means OSPF. O. And star here means, where is the star? The candidate default. It's the default route. Okay. And E2 means external route. It is a static route which is injected into OSPF. It is an external route. Clear, guys? Okay. So to send, or if you have any unknown packets, whether it's Facebook, whether it's Yahoo, whether it's Twitter, whatever is the packet, send it to R7. That's it. Clear? So this is the command to originate the default route into the OSPF. I suppose you have understood. So this is also the default route. Okay. In order to send to any unknown network, send it to 10.0.0.7. That's it. Clear, guys? Okay. So this is the OSPF. Okay. Any doubts? Anything? Okay. Now, yesterday I forgot to show you the OSPF packets. Okay, shall we see the OSPF packets? So here I have run OSPF. Okay, you can see these are the hello packets. We have been talking about the hello packets a lot. Okay, so you can see the hello packets. This from 10.0.0.7 R7. Okay, and the destination, you can see it is sent to 224. A multicast address which is having the IP 224.0.0.5. Okay, so now the hello packet and the OSPF header, and then you can see many things here. Okay, OSPF hello packet, you can see. So this is the hello packet, many things are there. Okay, so yes, even the hello packet has the information about DR and BDR. Who is the DR and who is the BDR? He has got the information. Okay, so R4 is the DR. We have configured priority, higher priority in R4. Okay, and that's why R4 has become the DR. Okay, and then based on the highest router ID, R, say I suppose, I don't remember, R3. Okay, R3 has become the BDR. Okay, sorry, R7 is the BDR. R3 should be. Okay, so yes, let me tell you, this is, say these are, say when you take the hello packets here, okay, this will have the correct one. No, BDR is 10.0.0.7 only. Just a moment.
We didn't rerun the SPF algorithm after changing it to passive.
Yeah, maybe we didn't, maybe, or we would not have changed the, say this thing. What do you say? Rerun the SPF algorithm. Okay, there also you need to rerun the SPF algorithm. Now let me just show. So here this is the OSPF, and let me stop it, or else it will go continuously. Okay, so now you can see here many packets. So I told you DBD, database description. Okay, so let me take here. So here you have. Okay, so you have DBD. Okay, database description, and I told you, say LSR or LS request. Okay, he is requesting for a network, some network he is requesting. Okay, link state request. Okay, this is something else. This you will study later in CCNP level. Okay, LSA type 2 and all you will study in CCNP. Now then LS update. LS update, it contains the network information. Okay, whatever the network is set, say this is the network 10.0.0.0. okay, so this is the 10.0.0.0 network, and this is the network related information. Say that subnet mask is there, and type 3, leave that, connection to a stub network, stub and all you will study it in CCNP. Now the metrics, and the metric is 10. Okay, and again after sending the, say what is it, the update packet, you will have the acknowledgement. Okay, LS acknowledgement. Clear, guys? So again let me take this here. So LS update. Okay, LS update here. Yes, actually what happens is that, let me tell you, So who will become the BDR here, guys? Why R7 has become the BDR? Anyone know about it, or anyone can think about it? R7, let me just take R7. Do show IP OSPF neighbor, do show IP OSPF interface brief. Okay. State is BDR. It's not because that we didn't run the SPF algorithm. Any idea why?
Physical interfaces.
I'll tell you. So what happened is that we have configured this. Okay, so previously let me show it to you, the previous thing before this. Yes, I'll tell you. Okay, so previously, before configuring that root or the 20 dot network there, BDR is 10. Okay, let me take the other one here. No, still R7 is the. Okay, I might have configured, or I might have taken that here. No, I suppose I might have configured. Okay, leave it. So what happened was, it is configured with the 20 dot network. Okay, now if you again rerun the SPF, let me rerun the SPF in R7. Okay, do show or in R7 do show IP OSPF interface. Okay, do clear IP OSPF process. Whatever. No. Okay, so I suppose it was because, say, we'll confirm it and tell you later. Okay, so I suppose it was because this IP was configured. Okay, but if this IP was configured, I'll confirm it and tell you later. Okay, my assumption is that if the IP is configured, then it is having the IP 20.0.0.1. Okay, yes, highest IP. Okay, so the highest priority, the one with the highest priority is R4. Okay, R4 is having the highest priority, which is 100. Okay, then going with this one, it is having 20.0.0.1, and this is having 11.0.0.1 only. Clear, guys? Okay, got it. So I'll confirm that once it's like when I do some research, I'll confirm that. Clear? And most probably that is because of this one only. Okay, now I was about to tell you some more thing. Let me just take this. Yeah, we were talking about the packets only. Okay, so here let me show this one here, update. So update, it's sent by 10.0.0.5 to so 10.0.0.7 now. So here update, and let's update. Student type. Yes, you can see here. So later I have advertised the default route through OSPF. I advertised the default route through the OSPF. So you can see in the LS update, in the LS update you can see it is generated, the source OSPF route is 10.0.0.7 generated by 10.0.0.7 or R7. Okay, now you can see the LSA. LSA, it's type 5. Yesterday we studied about LSA type 1 and type 3. Okay, type 1 was the network in this within the same area. It was called intra-area route. And type 3 was inter-area route. Inter means it's from a different area. Now you got type 5 here. Type 5. Type 5 means, say, it is an external route. The static, it's actually mentioned as static. Okay, it's an external route. And that is why it's called type 5 LSA. Clear? And when you check that network, it will be here. Okay, so it ought to be here. Yes, the link state ID is say 0 0 0 0, not that one. Okay, LSA type 4. Let me take the other one here. Transit type flag, advertised router is there. LSA, this is LSA type 1 only. Okay, so net mask. Yes, this is it. So link state ID and the net mask. Okay, so 0 0 0 0 0 and the subnet mask is also 0 0 0 0 is a default route. Clear, guys? And it is shared as external route, or it's shared as LSA type 5. And let me again tell you, suppose if you configure, say here it is, up to here it is OSPF topology, up to here it is OSPF topology, here it is EIGRP topology or RIP topology. Okay, suppose you got a network 80.0.0.0/24. So R7 will receive the 80 dot network via RIP, and these routes which is received via RIP or any other protocol can also be injected into OSPF or can be injected into the other routing protocol. So again the same thing, the reverse can also happen. Whatever network that you are getting via OSPF can be injected, or the exact word is redistributed. It can be redistributed to the other protocol, and that property is called, or that feature is called redistribution. Redistributing or sending the routes from one routing protocol to another. So when redistribution is done, it is sent, these routes are sent as type 5 LSA. Getting it? And this router which participates in 2 or more protocols, this is called ASBR router. It's called ASBR router, Autonomous System Boundary Router. Clear? Any doubt so far? Yes or no? So this is the OSPF and we have done it. Okay. Raman, any doubts? So now do we need a break, or shall we go with the next topic or new topic, switching? What do you say? Break. Okay. Then we'll give you a break, maybe for 5 minutes. So guys, we'll get back at 6:59, 7:05. Okay, 7:05 p.m. Yes. Okay, so now, yes, okay, so we'll be studying switching. So you know what is switching, right? Switching is the process of forwarding the frames. Here we'll talk about frames. So if you have a switch and if it is connected to these interfaces of a switch, so let me tell you what happens. Suppose F0/1, F0/2, F0/3, F0/4, F0/5. Okay, suppose you got multiple machines here. Okay, now say the process of forwarding the frame from one interface to another interface. So if at all the first machine is sending something to a fifth machine, say the switch will forward the frame from one interface to another interface. That's called switching. Now, so switches you got, say, you know, switching is an L2 process, and so it will be performed by an L2 device, which is the switch. And switch itself, you got two switches, two types of switches. The first is called layer 2 switch. It's called layer 2 switch. Okay, which will only work in layer 2. And now you got something called multi-layer switch. The second is called multi-layer switch or layer 3 switch. It's also called layer 3 switch or multi-layer switch or MLS. Okay, which has the capability to work in L2 and also L3, which has the capability to work as a router also. Getting it? Okay. Now let me tell you just the basic things. L2 switch and L3 switch. Okay, L2 switch, you can configure an IP address to the switch. So switches, you can configure an IP. Okay, and if you configure another IP, then the previous IP will be lost or it will become inactive. Okay, so and this here is IP can be configured to the whole switch there, to the whole switch. Router was having different interfaces and IP was configured to that specific interface. But for the entire switch, you will be creating an IP. Okay, for L3 switch, you can configure multiple IPs, no issues. You can configure multiple IPs and they will be active simultaneously. They will be active simultaneously. Clear? Okay. Now, the next thing. So switches also will have, say, the operating system inside it. Okay, and say whatever that commands that you were doing it in the router, you can do it in switches also. The basic commands, like taking, say, it has got 3 modes: the user execution mode, privilege execution mode, global configuration mode, like that. So whatever config, the basic config that you have did it in router, say that's a task. Okay, task do all the things, the basic thing, configuring the enable password, configuring the enable secret, the users, everything. Configure that in the switches also. Clear? Okay. So that is how. Say again, let me take the switch here and show it to you. Say, I suppose we have got the packet. The packet tracer somewhere here. So here you got a switch. Okay, now if I take the switch here and CLI, okay, it's loading. Okay, after loading, okay, now let me show to you. So this is the greater than symbol, which is the user execution mode, and executing the enable global config, privilege execution mode, configure terminal, global config mode, and say host name, you can set it, everything you can set, the basic things, everything you can set it. Okay, now the next thing, let me tell you the working of a switch. So before that, let me tell you, router consists of a table called routing table, which has all the known networks. Now switch consists of a table. Any idea what the table is?
MAC address.
Yes, MAC address table. It is not switching table, it is MAC address table, or it's also called CAM table. Content addressable memory table. So MAC address table or CAM table, that's what we call it. MAC address or CAM table. And obviously you can guess what will be the contents. It stores the MAC addresses of the machines connected to it. Clear? Okay. And that is why I told you, that is why it's called intelligent device, because it knows, or it stores the MAC addresses. So it stores whichever MAC addresses are connected to which all interfaces. Okay. So now suppose you have a switch here. So let me draw it neat. So you got a switch. And suppose you got 4 computers. Now this computer is having IP1 and suppose it's MAC 1. I'm not expanding the IPs and MAC and all. I suppose you know how to write IP and how to write the MAC. Okay, so suppose this is IP2 and MAC 2, and this is IP3 and MAC 3, and this is IP4 and MAC 4. Okay, now suppose if the first machine wants to send something to the second machine. So let me tell you what happens. You already know it. So the message will pass through each layers, right? And each layer will add the header. And finally, it will pass the network layer, where the network layer will be added, or the network header will be added. And say suppose this is the packet. Okay, so the source IP will be IP1 and the destination IP will be IP2. Clear? You already know it. Now, here the frame is there. Here the frame is there. Frame will be, say, like generated. Okay, or encapsulated with the packet. Now, the frame structure has the source MAC address and also has the destination MAC address. The source MAC address will be MAC1. The destination MAC address, what if it's unknown?
Default.
Default MAC address.
Not default MAC address.
Universal?
MAC address.
Universal MAC address means I didn't get that. Specific, be specific. You are right though. I suppose you were telling something, yes, and that is right almost. Anyone who tells the answer will get a what do you want? A 5-star, a Snickers, whatever you want. Sorry? Samosa. Okay, we'll buy you a samosa. For you, I'll buy a samosa. Okay. Universal broadcast address. Okay, let me tell you. So again, universal, are they going to fill the universal broadcast MAC address and send this frame? Is it like that? Be exactly. Okay, I mean, you can tell it precisely what you are meaning by that. So I just asked whether the destination MAC. So you are telling the broadcast, universal broadcast. So I'm asking whether this will be the destination MAC, whether this packet will have the destination MAC as the universal broadcast MAC address or not. Yes or no? Time's almost up. Okay, then you guys owe me, not samosa, you guys owe me 1, 2, 3, 4, 5, 6, 7, 8, 9 and 6. 9 plus 6, 15. 15 Kit Kat. Okay, so I'm going to tell the answer. What happens if the MAC address, they do not have the MAC address, then the ARP will be generated, or the ARP request will be generated. And the ARP request will be having the destination MAC, universal broadcast MAC address. Okay, but as you haven't told your the samosa, or say what
request, but you exactly said what will be added over there. So that's why we do the default MAC address. So
I asked you like this: what if the MAC address is unknown? What if the MAC address is unknown? Okay, so guys, remember when you come on Monday, I need to get my Kit Kat. Okay, yes. So now, so the ARP request will be sent, and that's a different thing. Okay, now if it is known, if the address is known, suppose they know the MAC address. So the MAC address here, the MAC address is MAC2. The MAC address is MAC2. Then they will generate the frame and will send it to the switch. We'll send it to the switch. Okay, suppose this is F0/1, this F0/2, this F0/4, and suppose it's F0/3. Okay, so now the frame will be sent through to F0/1 of the switch. Now let me tell you, the switch has got a property. The switch has got a property. So I told you about the MAC address or the CAM table, MAC address table or the CAM table. So the switch has got a property. If at all he is receiving a frame, an incoming frame's source MAC address, the incoming frame's source MAC address will be checked. It will be, sorry, not be checked, it will be entered in the CAM table. It will be entered in the CAM table, or it will be updated in the CAM table. So you can see here the source MAC address is MAC1. So the CAM table updation will take place first. So they will update the MAC address 1 or the MAC 1 is sitting in F0/1. They'll update it like that. Then they'll check for the destination MAC, whether the destination MAC is known to him or not. So whether the destination MAC is known to him now, is there any destination MAC here? The destination MAC is MAC 2. Is there MAC 2 here? No. If the MAC address is unknown, they are gonna send this frame to all the interfaces. Send this frame to all the interfaces except the source interface, and that's called flooding. I've taught you that, right? So the frame will be flooded, and only the required machine will reply back. He will reply back. He'll generate a frame back, and this frame will have the source MAC address will be MAC 2. Okay, the source MAC will be MAC 2, and the destination MAC will be MAC 1. Clear? Now it's an incoming frame for the switch, and the incoming frame's source MAC address will be updated in the CAM table. So he'll update it like that. We got a MAC 2 which is sitting in F0/2. Then they'll check the destination MAC, whether the MAC address is present in the CAM table or not. Whether it's present, guys? Yes. Now this time it's present. So he will not flood it, but instead he will send it to only that interface. Clear, guys? Now again, if at all the switch is first machine is again sending the frames to machine 2. Again it will be an incoming frame for the switch. Again the table will be updated. If it is already there, the source MAC address is already there, he'll update the timer. Okay, then he'll check the destination MAC, whether the destination MAC is present in the CAM table or not. Yes, this time it is present. MAC 2 is present in the CAM table, and so there is no need for flooding. He'll only send it only to that interface F0/2. Got it?
Yes.
So this is the process of switching. Clear, guys? Any doubts? Okay. So in the next class we will start with what shall I start? Say, ask me to start with switch interface state. Okay, switch, or not even switch interface state. Ask me to or start with telnet SSH. Then we'll go with switch interface states. Switch interface states. Okay, remind me on Monday to start with telnet. There are chances that I will forget the telnet and I may start with switch interface state or the other one. Okay, guys. Okay. So shall we wind up for the class for today? Yes. So let me stop recording.